A charge Q is placed at the center of the line joining two charges Q and Q. The system of three charges will be in equilibrium if Q is. The question, it is given that two charges are there. They are some distance apart and capital Q at the center. Let 2L be the distance between them. Since these two charges are positive, there will be a force of repulsion between these two. And since they are in equilibrium, there should be a force of attraction between these two. So that we can write F QQ equal to minus F QQ. Negative because there is force of attraction. So by Coulomb's law, we can write force equal to 1 by 4 pi epsilon 0 Q1 Q2 by R square. Here Q into Q by distance is 2L square equal to minus 1 by 4 pi epsilon 0 QQ by L square. Here we will get Q by 4L square equal to minus Q divided by L square. So that Q equal to minus Q by 4. Option D is the correct one. 4 charges plus 8Q minus 3Q plus 5Q minus 10Q are kept inside a closed surface. The flux through the surface is. By Gauss's law, flux equal to 1 by epsilon 0 total charge enclosed by the surface. So here total charge we can write it as plus 8Q minus 3Q plus 5Q minus 10Q is equal to 0. So flux equal to 0 divided by epsilon 0, that is 0. Correct option is B. Two electric point charges Q and 4Q are placed at a distance 6 meters apart. The point at which the net electric field due to both charges is 0 is. Options are given. In the question, Q and 4Q are at a distance 6 meters apart. We have to find the point at which net electric field is 0. So let us take this distance as x, and so that remaining distance we can write it as 6 minus x. So electric field due to plus Q, that is equal to electric field due to plus 4Q. Electric field equation for electric field is 1 by 4 pi epsilon 0 Q by R square. Here distance is x, so it is x square 1 by 4 pi epsilon 0. Here it is 4Q divided by 6 minus x. Distance is 6 minus x whole square. So we can cross multiply these two equations so that we will get 6 minus x whole square equal to 4x square. Let us take square root on both sides so that we will get 6 minus x equal to 2x or 3x equal to 6, which means x equal to 6 by 3 or 2. So this is 2 meter and the remaining will be 4 meter. So let us check the option. 4 meter from charge Q, not correct. 3 meter from charge Q, not correct. 4 meter from charge 4Q. 4 meter from charge 4Q. Option C is the correct one. Electric dipole moment is a. Options are vector, vector from positive to negative, vector directed from negative charge to positive, vector along equatorial line. We know that electric dipole means a pair of equal and opposite charge separated by a distance. And dipole moment we can write it as 1 of the charge into distance between the dipole. So here dipole moment, it is directed from negative charge to positive charge. So option C is the correct one. 20 joule of work has to be done to move an electric charge of 3 coulomb from a point where electric potential is 10 volt to another point where potential is nearly. We are moving a charge from one point to another. Let us say from B to A. Here at point B, it is 10 volt. At point A, we have to find out. Work done, equation for work done to move an electric charge from one point to another is Q into V. Here we should take the potential difference. So Q into VA minus VB. That is Q is given as 3 coulomb. Work is 20 joule into VA minus 10. That is VVA equal to 50. That means VA equal to 50 divided by 3. That is equal to 17 volt. So correct option is option B.